Welcome back. We will now complete the Knight's Tour Part 2, a description of a possible programming solution. We left off in Part 1 taking a look at the moves of the knight around the board, and you each did a little bit of the beginning coding to get the setup for completing a tour. Now we need to look at some of the problems and solutions that we have facing us. Our last conundrum, if you will, was the fact that the knight had different number of possible moves depending on where he was on the board. What would simplify our solution is that if we could treat every one of the squares in the same way. Can we come up with a way to treat every one of these squares on the board exactly the same? That would mean we could randomly select a number from 0 through 7, pull one of the row column offsets out of our moves array, use that to attempt to take a step. Let's take a look at a solution for that idea. First, let's investigate all of the different steps on the board. Here is my spreadsheet for the knight's moves on the board. What I've done is to investigate each square of the board and determine how many possible steps he has from each square on the board. I'm calling this my Knight's Tour heuristic because it helps inform us regarding his ability to take a step from these locations in the board. If the knight is in location column 1, row 1, then he only has 2 possible moves on the board. If he's in location 3, 5, then he has 8 possible moves on the board. If he's in location row 7, column 7, he has 4 possible moves on the board. A way to simplify this is to think about putting zeros to start in our board and then framing the entire board with 2 rows of -1s. Now I'm selecting -1 for the frame because if I put zeros in the valid locations, I can check for that number. When the knight goes to make a step, I can check, is there a 0 in that location? If there's a 0 in that location, then he can move there. But if it doesn't have a 0 in it, he can't move there. We'll consider it blocked. Now it could be blocked because he's already visited this location, or it could be blocked because he's off the board out there in the frame somewhere. But by setting up this board that is now 12 by 12 with a border of -1s around it, I can treat every location on the valid board in exactly the same way. Consider the knights in location 2, 2. That would be the 3rd row, the 3rd column. This corresponds to our original board as the very first row and column. He can now take any of the 8 possible moves, but we see that 6 of them will land him in the frame of the board. When we inspect that with the code, we'll see that there's a -1 there, which is not a 0. So he cannot take a step there, but he can at least check there to see if he can take a step. So what we've done here is to adjust our data structure to make the code less complex. I can now treat every square on the board in exactly the same way, and this will simplify the code immensely. So let's see what your job now is in completing the code for the Knight's Tour. We'll first take a look at the chessboard. The chessboard now has a frame size of 12. Rows and columns are set to 8 because that's the actual size of our board, and with the frame it's a 12 by 12. We declare board to be 12 by 12, and then the constructor for our chessboard, using the board length, is going to initially write -1s into the board. So we cover the entire board with -1s, and then we overwrite rows 2, through 9 and columns 2 through 9 with zeros. So we now have the chessboard set up 0 through 11 rows, 0 through 11 columns, with rows 2 through 9, columns 2 through 9, as our actual board that we allow the knight to move around. The constructor sets that board up for us. The 2 string has been adjusted to output only the valid board. Notice we have a nested loop here. We need the outer loop for the rows, the inner loop for the columns, and it's ranging from 2 through 9, and it will output the contents of the board. Now initially the board will have all zeros in it. If you want to see the framing of the board, have your 2-string method range from 0 to less than 12. That will show the entire board with the framing of -1s. Our set square method, I have removed the column and row adjustment. We will be making that adjustment inside the Knight Moves class. So when we set a square, we verify now that it's between 2 and 9, because that corresponds to the actual board. If it's a valid row, a valid column, then we take the input number and we apply that to that particular square on the chessboard. The get square just returns what's stored in that particular row and column of the board. Let's take a look at the Knight Moves. Knight Moves has a final or a const declared for complete tour equal to 64. So if the knight gets all the way up through step 64, that means he visited each location on the board exactly 1 time and successfully completed the tour. We have our private chessboard, K-board, our private moves array, that's size 8 by 2. We have 8 row and column offsets. Then we have the step number for the knight, his current row, his current column, his start row, and his start column. We have a random object created, and the constructor initializes the Knight Moves. So each column 0 is the offset for a row. Each column 1 is the offset for the columns. The step number is set to 0. The start row and the start column is set to 1, as is the current row and the current column. The get start position asks the user to give us the starting location for the knight's row and the starting location for the knight's column. Then we see that the current row is set to start row +1. The current column is set to start column +1. When we originally looked at this program, we had to adjust the current row and current column to -1 from the start row and start column. But because we framed the board, now if the user says they want to start in row 1, column 1, this will actually correspond to row 2, column 2 on our board with the frame. We call the set square method to assign step 1 to the current row, current column. So each time we update the set square, we will be incrementing the step number. Then we print the board. You will be writing the run tour method and the take a step method. We'll talk about those in a minute. Let's look at the 2-string method. The 2-string method just reports what happened as a result of running the tour. Okay, so let's take a look at what a sample output might look like. Here we see that the knight started in location row 8, column 1, and the tour ended after 43 steps in row 1, column 6. Now you will need to submit sample output and of course the digital copy of your program, and you will start with the code I provide. So you will need to just finish writing the run tour method and the take a step method. Let's go back to the code. So the run tour method needs to run the application, provide some instructions, and then call the get starting position from the user. Then you need to write a loop that attempts to complete the tour by taking steps. As long as he hasn't completed the tour and he can take a step, which means he's not stuck, he should continue to do so. But if he gets stuck, take a step should return false, or he completes the tour by taking 64 steps, then we are done running the tour, and we should just go ahead and display the results using the toString method. The preconditions and postconditions, there are no preconditions. The postconditions is that he runs the tour and reports the result. Now the night's tour will call instructions, which you should provide, the get start position, which is already written, and he should, in a loop, continue to take step until it returns false. Once that returns false, we know that he's stuck and can't move any longer. The take step method needs to generate a random number between 0 and 7, and this will correspond to the possible night move. What you need to do, let's take a look at the spreadsheet for a minute. If I start my night, let's put him in what the user would call row 1, column 1, but for us is row 2, column 2. When he attempts to move, we see that step 1 is not valid because it's off the board. Step 2 is not valid because it's off the board. But step 3 is valid, step 4 is valid, step 5 is not valid, step 6 is not valid, step 7, and step 8 not valid. So he only has 2 ways to move. Out of the 8 possible moves, he only has 2 valid moves. Either he takes step 3 or step 4. Given that we have 8 possible steps, what do you think would be a good number to assume that after we try this many times, those 8 random values, if he can't move, he's really stuck? So I think we could safely say if we try to step 200 times and the knight can't make a step, that we've exhausted all the possible valid steps. So that could be our criteria. So in your take a step method, you will generate a random number between 0 and 7, use that as the index to the moves array, add what's stored in the moves array column to the current column, and add what's stored in the moves array offset for the row to the current row, and look at that square. Does it have a 0 in it? If it does, then you can move the knight to take step 2 in that square. But if it doesn't, you want to increment a counter, maybe call it attempts, and try again. And you want to repeatedly try this until either he's tried 200 times and can't find somewhere to go, or he takes a step. Take a step will return true if he was able to take a step, and you've moved him on the board. Don't forget to readjust the current row and current column. But if you try 200 times and he can't make a move, then we can assume there are no valid steps for him to take, and that can return false. If you are having trouble using my shell for take step and run tour, go ahead and work the logic out on your own, but try to break it in at least to these 2 different ideas. One where you are continually trying to take that step, and when you're finished, you report the outcome. And the other take step that isolates him trying to make the move. Okay, try to get this done for Sunday night. If you're having a lot of trouble, send me an email. I do want to show you, and I will leave a line of code in the run tour where we actually call the toString method by using this. Remember that this is the current object. I'm going to leave that line of code in there for runTour, but you should be able to construct the loop that calls the take step and get your take step method to attempt to make a move on the board. Okay, I hope you have fun with this. I think it's an interesting programming problem. And once you get it running, go ahead and adjust a program that runs as many times as you'd like to try to get a complete tour. Happy coding!